Hello, Eric. Hello, Ryan. Hello.
Hello.
Are you alright?
Yeah.
Sit down, please. Okay, so today we're going to talk about an interesting problem, which is called two-sum. Ryan, so let's say given a number, a list, okay, so this problem is like that. Given a list like 2, 4, 6, 3, 1, okay?
7.
Okay, 7, 1. So given a list of numbers and a target, so this is the numbers, okay? Let's call it nums. Nums, terrible writing, anyway. So then there's a target, and is 10.
The target is 10. So you
Uh,
have to make 10 with
yeah.
5.
No,
Or
so
6.
yeah, exactly. So our target is to check if there are any two numbers, yeah, in this given list, if they sum up to 10. Yeah. If it is, you just return true. Otherwise, it returns false. Okay. That's a simple version. So, any thoughts? Any thoughts? How do we do it?
That.
I know. So, can you explain to me how would you do this? How would you check if they? Oh, look, this is a simple one because we got the 4 and 6 plus to 10, right? So how do we? So what's your general approach to solve this kind of problem? Ryan, any thoughts?
I don't know.
So how do you know it's that? How do you know given a list of numbers and a target? How do you tell computer to return true or false? Eric,
Huh?
how do you do it? You just look for the numbers.
Yeah.
How? Or you try different. I mean, you search, you enumerate all pairs, and then to see if they sum up to the target. That's one approach. Yes.
Yeah.
Okay. Can we do this like that? Okay. Can we do this? Sit down. Otherwise, the audience will not see the whiteboard. Please.
Look, I can do this.
Please.
Limbo.
Def. Let's call it two-sum.
Hey
Two-sum.
guys, can you see the whiteboard?
And there was a nums. And there's a target. Let's just call it T. Okay.
T.
Column. So we can iterate all the numbers, right? Yes.
You need to say T equals target.
That's okay. We just pass the T. So how we can do it? Let's say we first get a len equal. Let's call it maybe size equals len lum. Okay. So now we just need to check for right? That's one solution. For I in range range SZ. And then we iterate this, yeah? And then we iterate another one for J in range. But now we start from the
What's J?
start from 0 to I.
What's J?
J another variable. So I teach you about that later. So now we got it. So basically, let me. Where's the red pen? Okay, that's fine. So here we've got the I. Yes, I will be pointing to the first, second, third, fourth, and fifth, and J we're pointing to the start until but not equal to I. Okay. So now what happened is I got the numbers I and numbers J. So if that's the interesting part. Num I plus num J equals T. What should we do? So we found a pair I and J, right? Because if I is here, then J is here. I is here, and J is here. So numbers I plus num J equals what? The target, right? Then what should we return? Return. We return true or false, right? Return true. Otherwise, return false. Do you get it? Ryan, do you get it? Ryan? Yes? Sit down, please, Ryan. Eric. Okay, so Eric.
You dropped your.
Yeah. Look. This one. Okay, let's do this. Let's go through this example. Eric, look. SZ equals none, which is 1, 2, 3, 4, 5. So SC will be equals to 5, right? Ryan, listen.
Yeah.
Eric, listen, please. Look, SC will be 5, right? SC will be 5 because the length is 5. There are 5 elements. So for I in range SG, so what happened? So I will become the value of 0, 1, 2, 3, and 4. Am I right?
Yeah.
For Z equals range I, what happened? When I is 0, then Z will be nothing, right?
Yeah.
When I is 1, Z will be what? The range 1. Then J will be 0. So what does that mean? It means that the I, so this I pointer will point to this. Okay, when I is pointing to 6, then J will pointing from 2, 4, yeah? So the left side of I, right? When I is pointing 7, J will be pointing to 2, 4, 6. And when I is pointing to 1, J will be pointing to 2, 4, 6, 7. Do you get it? Yes? And then every time we have two pointers, then we just check if these two numbers added up to the target. If it is, we return true, right? Immediately. Otherwise, after these two loop, if we can't find any number, then we return false.
Yeah.
Got it?
Yeah.
So you see, if this I is 5, and if the number is there are 5 elements, and how many times the computer needs to check?
5.
Now when it look, this is 1 time, this is 2 times, and then 2. So that will be, that's okay. So that will be around 5 times 5 divided by 2, approximately, right? Right? Yes? Because when I is pointing here, then it needs to check 1, 2, 3, 4, yeah? 20 times, yes?
Then it must be
Yes?
about 12.
Yeah, something like that. So you can imagine when this n goes to very large, it needs the approximately n square divided by 2, right? Because it's when I is somewhere, it only goes to half of this I. Okay, so it's not very efficient. So how can we improve it? This is one method, okay? So how about we use a dictionary? Do you remember this dictionary? Okay?
Yeah.
This? What do you call it? Curly brace?
Yeah.
A notebook. Oh, remember the notebook?
Yeah.
Yeah? So
No.
the idea is we go through once. Alright, look, we go through these numbers. And then we put it in the notebook. Right?
Yeah.
Yes? And once we find it, if the target minus current number is in the notebook, so what happened? Look, I teach you. I have a notebook, right? I have a notebook. Notebook, remember, yeah? I have a notebook.
I have the writing on.
Yeah, this is the notebook, okay? And something like that. Maybe just like that, okay? So look, the first number, we're going visiting the number. First number is 2, right? Then the target is 10, right? Yes? So let's see. If 10 minus 2, what's the number?
8.
8. If 8 is in the notebook?
9.
No. Okay, so we continue, but we put a 2 here, right, in the notebook. When I go to the, sorry?
Why?
Because we seen this number, so we put it in the notebook, so we know it's there. Yeah? Okay, so now 4 is 10 minus 4, 6. Is 6 in the notebook?
Yeah.
No, we haven't put it in the notebook yet.
Oh yeah.
We haven't put it in the notebook, so no, right?
No.
So I'll put a 4 there, right? We visit. Okay, we come to 6. Is 10 minus 6 4 in the notebook?
Yeah.
Yes?
Yeah.
Yes, we found the answer. Look how easy is that with the notebook thing.
Yeah, but there might be lost.
Yeah, but for this, we just going through once, right? And this notebook is very fast. When you put it there, it's there. When you read it, when you check it, it's very fast, yeah?
Yeah.
How do you check the number is in notebook? You open the notebook and see, oh, it's there, right? Right?
Yeah.
So how do we do this? So this is simple, okay? So look, how do we do? We do it notebook. Notebook equals what? Curly brace. Curly brace. This represents the dictionary, okay? A notebook dictionary. Dictionary is the, what's dictionary? Have you read the dictionary before?
Yeah, we got one right now.
Yeah, so look,
It's very fast.
if you look at the table of contents, right? You will have this key and a page, right? You will have these keys, yeah, and the page, right? So you can look it up. So this notebook is the same. You have this key, and then you have this value, right? Right? Value. Key value pairs. So how do we do it? Notebook. Oh, in fact, you can also using the set. Remember we talked about the set before. Yeah? Okay, but it's quite similar. Okay. So notebook we go this for I in lambs. So what do we do? Look. If the target minus I is in the notebook, right? Is in notebook. Then we return true, right? Then we need to do what? We need to put the notebook. We need to put the I in the notebook. How do we do it? Notebook I equals true, right? We just do it true. And then here we'll return false. You see, simple. We only using 1 for, right? Eric, do you get it? Do you get it? Are you sure? Okay. So using the set is quite similar. It's quite similar. So we can replace this with what? With set. With set. And then this is the same. And this will be. We can do this notebook dot add. Add what? Add what? Add what?
Set.
No, add the number I. Yeah. Okay, and then this is return false, right? Do you get it? Can we have a better solution? Can we have a better solution? You don't know?
I don't know.
Ryan, please sit there. Okay, we can have another one. Look, I can teach you. Right? Look, this is another way. Yeah. How about? Look, we saw this number. Remember how do we sort it? Sort it. Make the numbers in order, right? So in Python, we can use this. We can use lambs. Alright, Ryan. Dot sort. Okay. That's it. Simple as that. Numbers dot sort. So this becomes 1, 2, 4, 6, 7. Am I right? Eric? So when we do this sorting, then these numbers will become in order. Yes? Will become in order. When you do this, Eric, Ryan, when you do this dot sort, these numbers will become in order. Eric, listen. Ryan, listen up, please. Okay? How about if I want to in the reverse order? Eric, Ryan, how we can do this? We can launch the sort and passing a key called the reverse.
And boom.
Reverse equals true. Okay? Reverse equals true. And then it will be in the reverse order, okay? Eric, listen carefully, please. I'm going to test you later, okay?
I just looked down for like a second.
Oh, okay.
And you haven't even got anything by then when I was going.
Yeah, so look, so now these numbers in order, that's the very interesting part. And our target is 10, right? We are looking for this 10. Yeah, these numbers in order. So how do we do it? We have the left, we point into the smallest. And we have the right, we point into the biggest.
Does it have to be in order?
Yes, that's why I have sorted. Look, dot sort. Yeah, you don't need to reverse. Reverse then will become from largest to the smallest. So lambs.solve, you will make the numbers in order, which is from the smallest to the biggest. So now we left pointing to the smallest number, right pointing to the biggest number. What's the sum of the numbers pointing at both?
8.
8, well done. So if A is smaller than 10,
Yeah.
yes, smaller than 10. Okay? We're looking for any two numbers adding up to 10. So tell me, should I move the left to the right or the right to the left?
The left to the right.
Why is that? Why is that? Why is that? Can you tell me? Yeah, we need to move to the left to the right. Why?
Because we need to make it bigger, but then
This-
it can't go to the right, so only the left.
Left, moving to the right, you become bigger, right? Too, yeah. Great, that's genius. Yes? Good job. Ryan, do you get it? Yeah? Okay, so now we're moving to the right. So now what's the sum?
9.
9. Is 9 smaller than 10?
Yeah.
So what do we do?
Move it.
Move it again, right? So 4 plus 7, 11.
Yeah.
11 bigger than 10, so what do we do?
Move the right to the left.
Yeah, because if you can't move to the right, because if you move to the right, then the sum will become bigger, right? We want to reduce it.
Yeah.
Yeah? So here.
Yeah.
And now 4 plus 6?
10.
Yeah, we got it. We found the answer, yeah? So now return true. Okay? So how do we do it? Look, actually look, if you look, you can write to, if I equals 0, okay, j equals lamb minus 1, then you can write in one line, yeah? Ij equals 0 lambs, okay? Lambs minus 1. And what should we do? Why they are not meeting in the middle, right? Why the I and j not meeting in the middle, right? Yes? If lambs I plus num j is target, then we return true, right? Yeah, we found the target, yeah? Am I right? Yes? Then okay, so now I write it this way, too small space. Here, come here, okay? Then we need to check again. If num
Say 4.
I plus num j, if it's bigger than 10, what should we do? What should we do here? You say it right?
Right move to the left.
So right minus equals 1, right? It means decrement, yeah? And else, what should we do?
Return false.
Not yet. Return false.
Left add equal 1.
Well done, wow. That's amazing, brilliant. Okay, and then at the end we return what? Did you just say it?
Return false.
Yes, well done, return false. So do you get it? Which one you like the best?
The shortest one.
The shortest one. Okay.
The easiest one. Okay.
How about you implement one approach in your computer? Ryan, Eric, I help you, okay? Yes, okay. Eric, you say it's easy. Go. I just introduced 3 methods, yeah? Okay, one last thing. Can you say bye-bye to the video, please? That's your happy time. Ryan, happy time.
Bye bye. Bye.
Okay.
Bye.
Okay, that's it. Enough. No.